So now we're going to apply the memoization technique to calculate or determine our Fibonacci number. So if you don't know what is actually Fibonacci number, say you have the first number 0 and the second number 1, and now the number that are after this will be the summation of these two. So for any number, it will be the summation of the previous two numbers. So the fourth number will be the summation of second and third one, that will be 3. In the same way 5, 8, 13, and so on. Now the thing is, how do we actually do it? For example, we need to calculate the fifth Fibonacci number. So Fibonacci number of 5th term actually. So for that we need to calculate the Fibonacci number at the position 4 and the Fibonacci number at the position 3. And when we have it, we actually add up these two things and get ultimately that number that we need. So for 4, recursively we'll go about Fibonacci number at 3, Fibonacci number at 2, and for 3 we have 2 and 1. For 2 we have 1 and at 0. Now the thing that we know, for Fibonacci number at position 1, we actually do it like 1. So if our n, the term, is 1, or our n is equal 0, we just return that number. Alright, so return just n, because at the position 0 the number is 0, at the position 1 the number is 1. And case otherwise, we just add up the previous two. For example, this f of 2 is nothing but f of 1 and summation of f of 0 basically. One thing you will notice here, that we are doing the same thing. We are calculating the Fibonacci number of 2, or the position 2, twice here, and Fibonacci number at position 3 twice here. So we are doing the repeated things, and that's why we want to actually utilize the memoization technique for this particular thing. Now how do we actually do it? So if we have a dictionary to store the particular thing, like what's the Fibonacci number at position 2, if we once calculate it, we set it to something that, for example, it is 2. So next time when we encounter the same sub problem, these actually are called sub problem. So once we encounter the same problem again, we just look up at the dictionary or the table that is it here. So if it is actually available, then we just return that from that particular table. In the same way, we calculate for Fibonacci number at position 3 once, and then we look up to the same thing after calculating once. If it is there, we just return that. So we are not doing anything twice, and that's why this memoization technique actually pretty helpful. Now I will show you both the things, the brute force method or the DFS, and then I will apply the memoization technique for this particular thing. So I'm going about our Sublime text. Let's say we're getting a new file named as fibo.py. So first of all, we have a function that is fibo, and it takes an argument for our DFS, I mean the brute force method. So if this number is 0 or it is 1, then we just return that particular n. And if it is not the case, then we just say that our value, or we just say that if it is not the case that n is not 0 or n is not 1, then we just say that return the Fibonacci at the position n minus 1 and add up to Fibonacci at the position n minus 2, because the previous two will add up to the nth Fibonacci number. Now if we apply the same technique, so for example we have something like result is equals Fibonacci at the position 3, then we print the result, then we will have 2. As you know, this is 0 at the position 0, 1 at the position 1, and 0 and 1 at the position it's basically 1th, and this goes on. If we want to print it like here, so or print Fibo in, actually this is a problem. Anyway, so at the position 3 this is 2, at the position 2 this will be 1, and that's how it works. Let me show you by calculating this by hand. So first of all we have 0 and 1, 0 and 1 add up to 1, 1 and 1 add up to 2, 1 and 2 add up to 3. So this is 0th Fibonacci, 1th, 2th and 3th. So that's basically how it works. Now we're going to apply the memoization technique. So we have a table where we will store the Fibonacci number. So our memoization technique, so define memoization Fibonacci, and it takes an argument in and the table, and in this case it will be our one dictionary, so fib table or dictionary. So first of all, what we do, if our n in this fifth table, then we just say that return fifth table of that n, and if it is not the case, then we check that if it is n equals 0 or n equals 1, then we say that our value will be that particular n, and if it is not the case, that means n is something else and it is not in the fifth table, then we say that our value will be memoization Fibonacci at the position n minus 1 plus memoization Fibonacci at the position n minus 2. And once we are done with it, then we say that our fifth table at position n will be storing the value. So ultimately we return that particular value. Now if our result is result 1, let's say, is memoization Fibonacci at the position, let's say 5, and we're sending an empty dictionary. Now result and result 1, control B, actually we have some problem here, I think. So it's an empty dictionary, this should not be a problem. Oh yeah, fifth table, the argument should be passed everywhere when we actually call the function fib table. Now it should work. So for example, result equals fib of 5. This should return the same answer. So that's how actually we can apply the memoization technique to calculate Fibonacci number.